look at the November 2022 question 2.1, this is a sequences and series question, and when we read through this question, we need to recognize that they are telling us that this is a geometric series. Now, if you have a geometric series, you are either going to work with the Tn formula, which is AR to the n minus 1, or you're going to work with one of two formulas. There are actually two forms of this formula that you can work with. So A times R to the n minus 1 over R minus 1. Or if you just swap the R and the 1 around. So if you say A times 1 minus R to the n over 1 minus R. That will give you the same answer. You can decide which of these formulas to work with. Now, in the first question, they are asking us to calculate the value of the constant ratio, which is R. They haven't actually given us the first three terms, which is usually what happens. They have given us the first term, which is 14. So that means that our A value is 14. We know that A is the first term. And they have given us the sixth term. So term 6 is equal to 448. Now we need to use this to calculate the ratio. Now what we're going to do is, since they've given us the value of a term, we are going to use the term formula. And we are going to rewrite term 6 as AR to the power of 6 minus 1. Because our formula is AR to the power of n minus 1, and n is the term number. So in this case, term 6n is 6. This actually gives us a value of AR to the power of 5 is equal to 448. Now we still need to find R. That's what the question is asking for. Luckily, we have the value of A. We know that A is 14. So we can substitute that value of A into our equation. So we can say instead of AR to the 5, we have 14R to the 5, and that is equal to 448. And now we need to solve for R from here. So we're going to divide both sides by 14. That will give us 32. And now from here, there are two things that you can do. You can say that the opposite of raising something to the power of 5 is taking the fifth root of that thing. So we can do that on both sides. And when you type that into the calculator, or when you just work that out in your head, the answer is 2. Or what you can also do is, from here, you can say that since we have R to the power of 5, we can rewrite 32 as 2 to the power of 5. So when my two exponents are equal, that would mean that my two bases will have to be equal. So R is equal to 2. This question was only worth 2 marks. The first mark was actually only for that line. So substituting the 14 and using the Tn formula for term 6. And then the second mark was for the actual answer of R equals 2.